Hello, welcome to In 5 Minutes. Mumbai University problem asked to find the voltage gain, input impedance and output impedance. Given is a potential divider biasing circuit, N channel, JFET. This is your gate, drain and source. IDSS VP is given in the question. For AC equivalent circuit, we need to find the value of GM. You know the equation for GM is twice IDSS upon VP into 1 minus VGS by VP. So for this we need to find the value of VGS, which we need to do using the DC analysis. Now for that we can find the voltage at the gate, that is VG, as by the potential divider rule 110K upon 110K plus 910K multiplied by 20. So this will give you VG as 2.15 volts. Since you know the voltage at the gate, you know the formula for VGS is VG minus VS. Right. Now we can find the voltage across the source as Vs is nothing but ID into Rs. That is, in this part, this is your source, this is Rs. Current flowing through the source is ID. So when you apply KVL, you will get this equation. Now you know Vg as 2.15 and ID into Rs is 1.1K. This is your VGS. Now from the Shockley's equation, we can write ID equals to IDSS 1 minus VGS upon VP the whole square. Now when you look at the question, the value of IDSS is given, value of VP is given, we don't know the value of ID and we have expressed VGS in terms of ID. When you substitute over here, you will get the value of ID as ID will be 3.3 milliamperes. Once you have got the value of ID, you can find VGS, which is VG minus VS, which is 2.15 minus ID into Rs. So this will give you VGS as minus 1.48 volts. Once you know VGS, you can find GM. When you substitute the value of VGS over here, you can find GM as 1.903 milliampere per volt. Now this we require for the AC equivalent circuit. Now how to draw the AC equivalent circuit? Looking at this, for the AC equivalent circuit, you can see this voltage source will be connected to ground. This capacitor will be replaced by a short circuit. This capacitor will be replaced by a short circuit. Similarly, this capacitor will be replaced by a short circuit. When this capacitor is shorted, this resistance Rs will become redundant. So when you draw the AC equivalent circuit, it will be, say, your gate, your drain and source. This is your gate, this is your drain and this is your source. Always you don't have anything between gate and source, open circuited. Then there is no resistance in the source. You can connect, you can assume that the source is connected to ground and the current flows from drain to source, whose value is GM into VGS. And since lambda is not mentioned, we'll assume that lambda is infinite and we not consider the output resistance, small RO. There is one resistance connected between drain and ground, which is your RD 2.2 kilo ohms. Then you have your output VO. Then you have R1 parallel to R2 will come to 98.13 kilo ohms connected between gate and ground, and then you have your input voltage VI. Now question is to find ZI. So when you are looking from this point, this will become your ZI, this will become your ZO, assuming that the current flowing is II. So when you apply KVL, it will be VI minus II, say resistance RI into Ri equals to 0. So you can see Vi equals to II into Ri, and Ri will be Vi upon I, which is nothing but your Zi. So Zi will be 98.13 kilo ohms. Similarly, you can find ZO, which will be your output resistance RD. So it will be 2.2 kilo ohms. So we have done with Zi and ZO. Now in order to find the output voltage gain, AV will be VO upon Vi. How we can write VO as minus GM into V pi into RD. Now GM into VGS into RD. It's not V pi, it's GM into VGS. You can write VGS in terms of Vi. That is, VGS is nothing but your Vi. So it will be minus GM into Vi into RD. This is your output voltage. So you'll get VO by Vi as minus GM into RD. So for this we have found the value of GM, and which will give you the voltage gain as minus 4.18. Why I have got this negative sign? Because it is common source. There is 180-degree phase shift between input and output. So I have got the negative sign. So this is the most important point for the common source JFET and common emitter BJT. The voltage gain will have a negative sign. Right? This is how you need to solve the problem for 10 marks. Thank you for watching in 5 minutes. For further concepts, kindly keep watching in 5 minutes.